Here's a binomial x times n plus 6 times n. Each of the two terms has the common factor of n, so we'll factor that out, and we'll get n times the quantity x plus 6. But we could let n stand for another quantity, 2a minus 3 in this case, and we'll substitute the 2a minus 3 in for n, and now we'll get a binomial, 2a minus 3, times another binomial, x plus 6. Well, let's look at it another way. We start with xn plus 6n, as we did before. We're going to let n be 2a minus 3, and we're going to substitute that quantity in for the letter n. And then we check to make sure that they have a common factor, only this time it's not as simple as just the letter n, it's the entire quantity 2a minus 3. But we can still factor that, and we get the quantity 2a minus 3 times the quantity x plus 6. Here's another, and we can see that the greatest common factor is a binomial, n plus 8, underlined as shown. So we factor out the n plus 8, and we get that times the quantity 2x squared plus 7. Here's another. We see that the common factor is n minus 2. But there's nothing there on the right term. But of course, we can always put something there. And of course, that's 1, because n minus 2 is the same as 1 times n minus 2. So now when we factor, we get n minus 2 as one binomial, and x squared plus 1 is the other. Here we are again, very similar to the last problem, except for a plus sign has now been changed to a subtraction sign. We still see that the common factor is n minus 2. We still see that there's nothing there, but we're allowed to put a 1 there. And so then when we go to factor, we have to keep in mind this subtraction symbol. So it's n minus 2 times the quantity x squared minus 1. And notice how the subtraction symbol is in that factor. But of course, that makes that factor a difference of squares. So we can factor some more. The first factor, n minus 2, can't be factored further, but the difference of squares, x squared minus 1, can be factored as x minus 1 times x plus 1. And now we've completely factored the original polynomial. Here's another one. We check. There is a common factor, 3n plus 3. We factor it out. We get the quantity 3n plus 3 times the quantity a, take away 7. This one looks a little different, but we handle this by factoring the first two and then the second two. First, we just make some marks to show where we're headed with our factoring. The common factor in the first two is a, and the common factor in the second two is b, so we factor them as shown. And then we look at the binomial factors, and they match. That's what we're after. And because they match, we can factor the quantity a plus 6 out of each term. And what we're left with is the quantity a plus 6 times the quantity a plus b. Another example. There we've divided into the first two and the second two. And the first two have 5a in common, and the second two have 6n in common. Then we check, and we're happy because the binomial factors are identical, and they need to be, or we couldn't factor any further. And there you have it, 4a plus 3b times the quantity 5a plus 6n. And yet another. We divide out the first two and the second two. The first two have a common factor of a, so what's left behind is a plus 5b. And the second two terms didn't have a common factor, so we just brought them down and put parentheses around them. And then, of course, we remember from a couple previous problems, we need to put a 1 right there. And then we look at our two terms, and we recognize that a plus 5b is the common factor in both. So we can factor that out, and we're left with a plus 5b times the quantity a plus 1. And here's one with two subtractions in the third and fourth terms. So to try not to make a sign error, we're going to change subtract 7a to add negative 7a and subtract 5c to add negative 5c. And we group up the first two and the last two. And the first two have a common factor of b. The last two don't appear to have a common factor, but we've seen this before. We have 7a plus 5c in one group, negative 7a plus negative 5c in the other. We factor out a negative 1 in the second group to change it to 7a plus 5c, all times negative 1. And now these binomial factors match. So we have 7a plus 5c times the quantity b plus negative 1, or as more commonly written, b take away 1. We'll try another example. In the first two, our common factor is a. In the second two, our common factor is 4. But we look at those two binomial factors, and they're opposites of one another. One is 6n minus 3, and the other is 3 minus 6n. So we're going to rewrite both of them as adding the opposite. And then in the second group, we're going to factor out a negative, or negative 1. You don't actually see the 1, but when you factor out a negative 1 and multiply it times the 4 that's already there, you get negative 4. But the 3 changed to negative 3, and the negative 6n changed to positive 6n. Then we're going to write both binomial factors in the same order. We're allowed to do that because of the commutative property. We underline them just for emphasis that they are the same. And here's our answer. 6n plus negative 3 times the quantity a plus negative 4, or more commonly written, 6n take away 3 times a take away 4. Well, here's 4 terms. And the common factor of the first two is 2n squared. And the common factor of the second two is 3. But our binomial factors don't match. One is n minus 5, one is n minus 4. They're close, but they don't match. And we can't make them match by factoring out any negative 1s. So we stop here. This particular polynomial is prime. If a polynomial has 4 terms, find the greatest common factor of the first pair of terms, then find the greatest common factor of the second pair of terms. Look to see if the two factored terms share a common binomial factor. If so, write the polynomial as a product of two binomials. This is called factoring by grouping.